Okay, I think we can start. Welcome everybody. This is the third sustainability webinar organized by E-SWAN. E-SWAN is the European Space Weather and Space Climate Association. As scientists, we are not only observing our physical environment, but we have unfortunately also an impact on it. And therefore it's appropriate to question the sustainability of space sciences, and in particular of our space weather and space climate community. Today's speaker is Dr. Andrew Wilson. He is a lecturer at Glasgow Caledonian University, GCU. And his research mainly relates to life cycle assessment and everything that is included in that, with a particular focus on the space sector. In today's talk, Dr. Andrew Wilson will talk about the space sustainability paradox. What is space sustainability and how can it be achieved? Andrew, the floor is yours.
Thank you very much, and thank you for inviting me to give this seminar today. I hope you can all understand me through the thick Scottish accent, because I know it's not always the easiest accent in the world to understand. Like was said, I am from Glasgow Caledonian University. The reason my affiliation is different on this slide was because a lot of this work was done through my previous employment, which was the University of Strathclyde, and I've only just switched over to Glasgow Caledonian University only a few weeks ago. So what I want to talk about today is the space sustainability paradox. So firstly, before we even get into that, what actually is space sustainability? How do we define that? And how does the space sustainability paradox fit in with that? And can space sustainability be achieved? How can it be achieved, or can it even be achieved? So I want to start by talking about the space sector and how it's growing. So I hope that this isn't coming as a surprise to many of you. The space sector in recent years has been growing. And what this graph in the top right-hand side of your screen shows, and I appreciate the axes are a little small. So on the x-axis is the years. So every year from 1957 through to 2022. And on the y-axis is the number of launches. At the very top there is 200 launches. And what we can see really since kind of 2004, that the number of annual global orbital launches has been increasing. And this has primarily been because the cost of launch is getting a lot cheaper, which means that we've got more ability to get into space. Now, I'm not going to talk about equitable access to space today because that is another issue. But the main point I would like to make here is that the number of launches are increasing. 2022 actually set a new record for the number of launches, and 2023 is set to actually beat that as well. And on these launches, the number of satellites that we have been placing into orbit has been increasing and increasing. And again, last year, 2022, we set a new record for the number of satellites that we actually placed in space. Now, that can be seen as both a good and a bad thing. It's a good thing because this growth has meant that we have got more spacecraft in orbit, and that increases our ability to actually address societal challenges. So we can acquire space data and we can use it on the ground. And a very good example of that was the Montreal Protocol. So a satellite noticed that there was an ozone hole over Antarctica. We managed to use data to quantify that, and that then allowed us to put in place a policy that phased out chlorofluorocarbons, and we actually are now seeing the ozone hole starting to repair itself. The problem is that the more satellites we're placing up there to monitor our environment is also heightening several critical aspects. So one is the number of space debris that is in our orbit. So these are kind of fragments or dysfunctional satellites that are congesting our orbits. It's also congesting our orbits even with operational satellites, which makes kind of ideal orbits more challenging. And on top of that, it's also increasing our environmental footprint. So the environmental footprint, I mean to Earth. So really you can see there's a paradoxical situation really starting to develop here, where actually the use of space to support the SDGs is becoming unsustainable from the perspective of both our Earth and the space environment. And this really is what we call the space sustainability paradox. And this phrase really came in October 2021, where my former supervisor and I used the phrase in another online webinar called Space Sustainability for the Next Century. And that was ahead of a COP26 event, which took place in Glasgow at the Glasgow Sustainable Landing Hub. So let's start with the basics. What actually is space sustainability? Well, in 2017, the United Nations Committee on the Peaceful Uses of Outer Space, or UNCOPUS, released the guidelines for the long-term sustainability of outer space activities. And these were several years in the making and really are the first international guidance on space sustainability. And a really good part of this was it created the first definition of space sustainability. So they define this as the long-term sustainability of outer space activities as the ability to maintain the conduct of space activities indefinitely into the future in a manner that realizes the objectives of equitable access to the benefits of the exploration and use of outer space purposes in order to meet the needs of the present generations whilst preserving the outer space environment for future generations. So there's a lot of tie-in with that definition, with also the 1987 Brundtland Commission report, which really was the front runner for the definition on sustainable development, which was sustainable development being development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So that then begs the question, is space sustainability actually an environmental issue, or should we see it as an environmental issue? So if we're to see it as an environmental issue, we then need to define what actually is our environment. So according to the Oxford English Dictionary, they provide two definitions. The first one being, they say that the environment is the surroundings or conditions in which a person, animal, plant lives or operates. Well, actually, the last time every human being that has ever existed was on the face of planet Earth was November 2000. And the reason for this was because the International Space Station has been continually occupied since that date. So in that way, we could argue that actually space is, surrounds us, it is an area that we as a species live and operate. The second definition states that the environment is the natural world as especially affected by human activity. Again, I would ask, is space not a natural phenomenon we're affecting? So we as a species pretty much came from space. Carl Sagan famously once said we're made of star stuff, but we have also had a negative impact on space. Like I said in the introduction slide, we've overcrowded our orbits with satellites and we've polluted space with debris. And this image on the right-hand side kind of shows you the magnitude of that. Now, of course, those dots are not to scale, but it shows you the magnitude of the amount of space debris that is currently in our orbit around Earth. So my question really then is, should we actually define space sustainability or update it to actually reflect space being an extension to our own environment? And that's what we look to do here in Scotland. So in Scotland, we have an organisation called Space Scotland, and we created the first ever, at least what we believe to be the first ever national roadmap for space sustainability worldwide. And in this roadmap, there's various milestones that we are looking to achieve in order to actually go towards net zero. They cover very many different aspects. But importantly, what it also did was it redefined the definition as defined by UNCOPUS. And it did that through consultation with various industry stakeholders to make it more relevant from a Scottish perspective. So you can see kind of in blue and in bold the main changes to that. So the first part, so the main thing is there's a second paragraph which I'll come to just in a second, but the main change now reads that the long-term sustainability of outer space activities on ground and in orbit is defined as the ability to maintain and improve the conduct of space activities indefinitely into the future in a manner that ensures continued access to the benefits of the exploration and use of space for peaceful purposes in order to meet the needs of the present generations whilst preserving both the Earth and the outer space environment for future generations. But what I think is really key to note is the inclusion of this second paragraph, which states that space sustainability also requires promoting the use and environmental benefits of space data and recognising the need for launch and in-orbit activities to be carried out in an increasingly responsible and sustainable manner. And I'll come back just in a second to why that is so important, let's say, to consider. Now, in saying that, we're not naive. We know that, of course, there are probably still some problems with this new definition. So the first one is, of course, it is still very broad. So what this definition actually means, it could be different to different people. So if you ask somebody who's a space data scientist, they may come to a different interpretation to somebody who is looking at space debris compared to somebody who's interested in the environmental impacts of launch, for example. So really, there is, if we're going to move towards a sustainable space economy, we need to understand what issues are actually covered within space sustainability. And secondly, the definition also implies that there is a trade-off, and this is particularly the second paragraph, so it implies there's a trade-off to be made between the need to acquire space data so we can address social issues on the ground, but also the reducing or lessening the environmental footprint of the space sector. Now, this is quite problematic because this could be difficult to achieve in tandem, or perhaps they're actually just completely inharmonious with one another because they have, of course, got a conflicting focus. So let's kind of try and tackle that first issue. So what issues should space sustainability cover? Well, what we did was we really looked at the COPUS guidelines. We looked at the 2030 Agenda for Sustainable Development. We dived into the Scottish Space Sustainability Roadmap, and we looked at various other sustainability journal papers and just trends within the industry. And really, we can consider that there are three, let's say, pillars or overarching pillars that can be used to describe space sustainability. So the first one is sustainability from space, and that really looks at how space can be used as a platform to either directly or indirectly address global problems. So indirectly, we're talking about the use of space data. So we acquire data from satellites that are orbiting the world. We, send that to the ground. We process them, assimilate the data, and we can use that in our decision-making processes. Directly, there's also other technologies and aspects that have been proposed, such as, for example, space solar power. And that's got a lot of renewed international attention everywhere, from Japan to China to Europe to the UK to Canada and the US. And that's an idea where you collect solar energy in outer space and wirelessly transmit that to receiving stations on the ground to use as a form of renewable energy. Why would you want to do such an approach? Well, the sun is always shining in space, so it's a form of baseload renewable energy. So that is kind of the idea behind Pillar 1. So space essentially as a platform. The second pillar is looking at sustainability in space. So this is seeing space itself as a natural resource. So it's a resource we want to preserve. How do we preserve it? Well, we need to address the space debris problem because, of course, we are essentially littering in space. I would argue that that is not a good sustainability option because it's not managing the problem, let's say, but we'll again come back to what is kind of that in a little later. But it's also a resource that we need to exploit. So, how can we actually use, for example, asteroids or mine asteroids in the future so that we can turn Earth, what was traditionally seen as a closed loop system, into an open loop system, therefore reducing our dependency on resources on the Earth. And lastly, we also, space is a resource that we should explore. So it also is very important for helping us understand our place in the universe. And also quite commonly forgotten about, but equally very important, space is very important for trying to attract more young people and particularly females nowadays into STEM subjects as well. So really it's an important aspect for the future of the subject. And then thirdly, we also have sustainability for space. And this is concerned with protecting the terrestrial environment, so our Earth system, from the impacts that our space activities have in that. And that's everything across the entire life cycle. So everything from the design to the extraction of materials, the production and manufacturing, the testing, the launch campaign, the transportation, the launch itself, the use. So people think when we're in space there's no impacts, but actually ground stations are very energy intensive. And then of course the end of life, whatever that looks like. Now, in saying that, we can also combine those latter two pillars to form one singular pillar, and that is sustainability of space. So that then brings us to the space sustainability paradox. So this really is what we define as where the increased use of space to support sustainable development leads to heightened adverse impacts to both the space and also the Earth environment. And it's really depicted through this diagram you can see on your screen. So the more that the space sector implements space applications and technologies which are aimed at positively contributing towards sustainable development challenges for the benefit of our species, the less sustainable the space sector actually becomes. Now, there are a couple of nuances to this. So, of course, not all space activities will necessarily have a sustainability element to them, but they will impact the sustainability of space. And on top of that, I want to be very clear that this presentation is no way a way to demonize the fact that we're putting out we're putting satellites into orbit. Of course, our modern day society relies on this data. What we need to do is make sure that we balance what we're putting in space with the sustainability of space in a way that we can still achieve sustainable development here on Earth without impacting our natural environment. So I don't want to underplay the significance of space data, like I was saying. So of course we can't see satellites with the naked eye unless you're using a telescope or you're in a very clear night. Certainly in Scotland, with how cloudy it is, you won't see anything at night. But all these satellites do play a very critical role in achieving the 17 Sustainable Development Goals that are defined by the 2030 Agenda for Sustainable Development, which is this document which is indicated on the bottom right of the screen. And Earth observation and geospatial information, so GNSS, are already recognised specifically in this report as being crucial for the delivery of the SDGs. And in a joint study by UNUSA and the European GNS Agency, which was called Space for SDGs, they actually found that all 17 SDGs were positively impacted by space applications, and that actually EGNSS, so the European GNS system, and Copernicus alone actually contributed to 65 out of the 169 targets directly. So that's almost 40% benefiting from those two missions alone. But in saying that, how we use that data is not actually that great. So space data is only actually integrated into the measurement of about 10 over 232 indicators that are used to measure the SDGs and their targets. So it's not that we don't have enough satellites, we're just not using them as well as we actually could. And like I said earlier in the class, just to kind of demonstrate the importance, like I said, it was the ozone hole discovered over the Antarctic was due to a satellite, which led to the Montreal Protocol, which I believe is the most successful global environmental treaty that has ever been adopted. But the flip side of that is that it's leading to a growing population of space debris, and the European Space Agency track this through their space environment model called MASTER. And as of the latest figures taken from their Space Environment Report of 2023, they estimate that about 34,000 debris objects exist that are larger than 10 centimetres. There's about 900,000 from a centimetre to 10 centimetres, and 128 million debris objects from a millimetre to 1 centimetre. These are travelling at phenomenal speeds, roughly speaking about 7 kilometres per second, which is multiple times faster than a bullet. So you can imagine the damage that one of these debris objects would do if it was to collide with an operational spacecraft. But so what actually are these debris objects? Well, there's a variety of different things that they could be. So they could be rocket bodies, they could be dysfunctional satellites, they could be payloads, there could be fragmented bodies. There was actually an astronaut who actually lost a spanner from the space station, which has now become a piece of space debris as well. But the problem really here is that our changing use of orbits and the increase that we're experiencing in launch traffic, combined with these dangerous debris objects, and the fact that we still have limited post-mission disposal success, it's leading to a potential where we could see something called Kessler syndrome start to happen. So for those who haven't heard of that term before, Kessler syndrome is simply the mathematical singularity where an object will collide with another object, causing it to fragment. And those fragmented pieces will then go and collide with other objects, causing a cascading effect. And what that could eventually do is leave space completely inaccessible to future generations. That's not just human spaceflight, that is all types of kind of spacecraft being in orbit. Imagines kind of something like gravity. I mean, of course, not gravity is a bit of a stretch, but imagines kind of something like that. So Kessler syndrome is the mathematical point where those collisions begin to happen, and the problem is that they could begin to start just a collision or two a year before they start to scale up. And some have actually said that perhaps we've already that Kessler syndrome point has already been. We just haven't noticed. A lot of debate about when that will actually happen. But the scary thing, really, and the part I want to emphasize here is that ESA have said in their space environment report that even if no further launches into orbit actually happen, we still expect that collisions among space debris objects that are already in space will lead to further growth in space debris. So what we can see in this graph on the right, the red here, we can see kind of the prediction, let's say, we're extrapolating our launches and the cumulative number of catastrophic collisions that we would expect going into the future. And this kind of grey-black one at the bottom would be if we stopped all launches today. And you can see it still increases well into the future. So there really is a need here, as my point, to actually address this situation and try and deal with the space debris problem. But in parallel, it's also creating environmental burdens. So this kind of analysis, let's say, was the front runner to another one we've done. So there's been a slight update in this, but I thought I would show you this anyway. And what this is showing is the estimated sustainability impact of the space sector. And we did this across two scenarios using a streamlined life cycle sustainability assessment approach. So we did this for all launches in 2018 with our satellites, and then we also did a future scenario where we looked at how access to space, mega constellation space tourism, moon or Mars colonization would increase space activities to around 750 launches a year and 5,000 spacecraft a year. And we modelled that through the Strathclyde Space Systems database, which is one of only two life cycle databases for space systems to exist, the other one being the ESA Life Cycle Assessment Database. And really what we try to do, so the x-axis is the contribution to annual worldwide impact. So that's the level that we currently pollute, if you like, at the moment, whereas the y-axis is our contribution to planetary boundaries. So that being the ecological threshold in which the planet can sustain. And we did that across a wide variety of environmental media. So everything from air acidification to climate change, eutrophication, ozone depletion, photochemical oxidization, toxicity, water consumption, so on and so forth. And what we found was that in kind of 2018, the results were fairly insignificant. So, contribution to planetary boundary and worldwide impacts, less than 1%. And just for kind of reference, the global aviation industry for climate change represents about 2 to 3% of kind of CO2 emissions per year. But in scenario 2, when we actually scaled this up, we start to see the results become a lot more significant. So we see climate change, for example, contributing contributing almost 2% to the planetary boundary. We're seeing the likes of air acidification contributing about 5% to annual worldwide impacts, same with ozone depletion. So really what this is kind of showing is, as we scale up our industries, our impact is going to increase. And we need to respect the fact that perhaps our environmental impact will be bound by environmental limits. So let's look at the current state of play. So space itself is recognised as a global commons, and a global commons, just for reference, is a place where the resources are shared and accessible to all. So there's no single governing power or country. So as I say, space is already recognised as this in international law. There's four areas that are recognised. So one is space, the other is the atmosphere, another is the high seas, and the other is Antarctica. But despite it being recognised, many states, such as the USA, don't actually recognise it as such. And the reason for that really is because, well, why would they? Because it would threaten their position as a global space power if they did, and what they could actually do in space. Now, as well, one thing I like to also say is space is not completely lawless. There are laws in place, but the landscape of the space sector is vastly different compared to the time when these legislative texts were actually written. So what have been these main changes? Well, firstly, sustainability was not a concept when they were written, so they're not included within these texts. At the time they were written, space was mainly a public sector, so it was governments that were going. But new space, we're seeing more and more private entities going into space, so there's more actors than there were when they were written. And I suppose the main one, and this is an ongoing challenge as well, is that technological progress has also vastly outpaced the pace of legislation implementation. And as a result, legal systems are actually not anywhere near comprehensive enough to actually address space sustainability at the minute. So there's a need for some form of international body such as the UN to at least maintain a central role in managing and promoting the sustainable use of space. Now I say managing and promoting because the UN itself cannot dictate to member states what they must or must not do, but they would be at least a good coordination body. And the other thing that's also quite important is, are we actually going towards an impending tragedy of the commons in space? So, like I said, space sector is growing, and these growth will be kind of constrained by ecological limits, or at least they should be constrained by ecological limits. And these ecological limits can also be defined as tipping points, and these are the critical threshold, kind of like a planetary boundary, that when crossed will lead to a large and often irreversible change to the Earth system and could potentially drive it into a completely new state. And the reason I mention this here is because these tipping points are actually linked to the tragedy of the commons, which you can kind of see at the bottom left-hand side. So here it's a case of, different people wanting water using a shared resource. One person goes, I'm going to take as much as I want without not thinking about the interests of everybody else. So another user is then affected because there's less and less water becoming available because they're depleting the resources faster than they can regenerate. So again, the basic idea is that the common resource, which are not regulated by formal rules, become depleted through individual actions that neglect the well-being of society in pursuit of personal gain. So really, that kind of definition of it, you can kind of see or envisage why the tragedy of the common scenario in space could actually play out without proper regulation. Because at the minute, we're failing to manage our orbits as a global commons, and that undermines our safety, our predictability, and essentially could threaten space accessibility for future generations as well. So what is the future going to look like? So, despite the fact that the space sector is continuing to grow, what we are trying to say in this paper is that eventually there will be a reduction regardless of what scenario plays out. So this is, regardless of whether we have business as usual or whether we implement a space environmental management approach. And there's two reasons why this would happen. So firstly, if we look at the space environmental management approach, essentially what would happen is we would increase the number of active satellites being placed into orbit, and then a policy will come into place. And this policy will limit the number of active satellites that can be placed into a particular orbit based on that orbit's carrying capacity or the environmental threshold that we talked about earlier. If that scenario doesn't play out, the second scenario that would is where a tipping point is reached. And what would happen in that case is that Earth's orbit would become extremely saturated and place them into a new ecological state. You could essentially trigger Kessler syndrome, which means that launching satellites might not only be not technically possible, but either also potentially no longer socially, politically, or morally acceptable as well. So that's the kind of the blue line we can see in the right-hand side of that image compared to the red line, which would kind of plateau, if you like, if we put that policy into place. So what we need to really do here is we need to rethink space sustainability, so how we think about it. And really what we're proposing here is we think about it from a triple bottom line perspective. So that is looking at it not just financially, but also from a social perspective and an environmental perspective to ensure that we respect the limits of our planetary boundaries whilst addressing the social foundation. So planetary boundaries we spoke about a little bit more. So these are the anthropogenic perturbations of the Earth system in relation to safe operating thresholds. There's 9 defined. There's one in bold you can see there, and I'll come back to that in a minute. But so that you're looking at climate change, ocean acidification, ozone depletion, air pollution, for example. But on top of that, there's also a need to address the social foundation. So this is the basic human needs that have to be met in order to avoid critical human deprivation. And this is something that space is critical in supporting. So really, the good way to show this is through this image on the right, which is called the donut model of social and planetary boundaries. And it was proposed by Kate Raworth in 2017. The main problem here really was that actually space was missed out, which is why it's highlighted in bold. So we are suggesting that we include orbital space depletion as another boundary and explore the full ramifications. So what this model is essentially saying is that in the middle we see the social foundation. We see, like for example, food, water, health, education. These are all things that space missions can help to try and achieve or attain. But in attaining them, we need to make sure we're not overshooting our impacts with regards to climate change, air pollution, ozone depletion, land conversion, etc., etc. So there is this kind of lighter green circle, which is what we call the safe and just space for humanity, and it's within that circle that we need to live. So really what we're suggesting through this model is we need to actually look at the full ramifications of any space sustainability policy or action before we actually call them sustainable. And I've got an example on this slide. So one example is a space mission being in full compliance with the IADC space debris mitigation guidelines. So these guidelines essentially tell you that within 25 years of your spacecraft ends of life, it must be deorbited. So let's have a look at that and run that through this model. So firstly, of course, the social foundation is supported because through the goals of the space mission during its life cycle, so again, big tick. You're deorbiting the spacecraft from low Earth orbit at the end of life. You're re-entering it into the atmosphere. It's completely burning up. Therefore, you're lessening the orbital space depletion planetary boundary. Again, another big tick. However, the issue would be that this action actually pollutes the upper atmosphere with compounds that would then affect the climate change and ozone depletion boundaries. Beyond that, you're also losing the resource value. So again, there's resources on that satellite, but you're essentially vaporizing them, turning them into kind of compounds in our atmosphere. And that increases the pressure on other planetary boundaries and social foundation because we then need to find new virgin materials to create additional spacecraft products or space missions. Now, my argument here very much is that this is actually not managing the problem. It is simply shifting the pollution from one form to another. So does this action actually enable space sustainability, or is it just replacing one problem with another or several others? There's also other issues that are exacerbating the space sustainability paradox problem. So one kind of issue is that, I've been to many different space sustainability talks and panel discussions. You'll be surprised how many stakeholders cannot or do not make the connection between sustainability from space and sustainability of space. There is a lack of understanding there that the two are very much interconnected. On top of that, the space sector itself, like I've just shown you in that last example, doesn't actually consider the full ramifications of a space sustainability policy or action. As I say, it's not managing the problem, it is simply shifting one form of pollution to another. We're also seeing more and more irresponsible behavior becoming apparent. Okay, again, economic gain, profits, or even for national strategic goals, and that is leading to reduced orbital carrying capacity. We're seeing more and more spacecraft being registered at the ITU, and it's becoming quite alarming. And there's also, as observed by the European Space Agency and us at Strathclyde and GCU, greenwashing is already becoming very much prevalent in the space industry for the purposes of ESG reporting. They're making these sustainability claims without any transparency of where the claims came from. Have you done a baseline assessment? Have you actually calculated how sustainable you are? If you have, where's the evidence of that? So again, this is becoming a bit more of an issue in industry. And I suppose just to kind of conclude this slide up, really we are not learning from the mistakes that other industries have made. The space sector, where it was exempt from key environmental legislative texts, a good one was actually the Montreal Protocol. It actually missed out the launch industry, despite it being the only form of man-made pollution to inject ozone-destroying compounds directly into the stratosphere where the ozone layer actually resides. But a good example I like to give is actually even our terminology. Our terminology is just completely misaligned with any other industry. So you may have heard the term high-performance green propellant. Let me be very clear, there's nothing green about these high-performance green propellants. The green just means they're not toxic. We've actually done, ESA have done a study, TU Delft have done a study, at Strathclyde we did a study, basically comparing different types of propellant. And actually we all found the same thing, that if you compare hydrogen to the likes of LMP103S, hydrogen performs better environmentally on every impact with the exclusion of the toxicity impacts. So we're looking at 16 different environmental impacts. So again, just because something says it's a high performance green propellant doesn't actually mean it's environmentally friendly, and it's very important to also just remember that. So what actually needs to kind of be done here to actually achieve space sustainability? Well, I suppose we need to counterbalance this sustainability from space with the sustainability of space. Okay, so we need to do that if we're going to avoid that tragedy of the common scenario actually playing out. And the way that we can try and do this is create new avenues to talk, facilitate multi-stakeholder dialogue, international cooperation. The problem with the space industry is there's too many NDAs, people not willing to talk to each other or trust each other. But we really need to promote and strengthen stability here. We need to promote and strengthen our security, our regulation around these issues. And really what these discussions really need to focus on is how do we actually create a circular space economy that recognises space as a global commons with tipping points. And really for me, the idea here would be that you have to consider the use or reuse of space resources that includes in-orbit servicing, repair, manufacturing and recycling based on the 3-0 framework you can see on the right hand side of your screen there. So really what we're proposing here is this 3-0 framework. So 0 debris proliferation to maintain the necessary orbital carrying capacity. So again, making sure that we are not just not creating debris, but we're also actively removing it. Number 2, we're creating 0 unnecessary or unavoidable impacts to the Earth environment to avoid breaching planetary boundaries. So the idea here is when you design your system, measure your emissions, then try and redesign to lower your environmental without compromising the technical aspects of that mission. Now, I'm not to say that it's going to be 0 impact, because that would be completely impossible, but it is reducing the impact as far as practically possible. And thirdly, which I think is probably key to enabling both of the above, is zero unsustainable use of resources, and that starts, in my opinion at least, with an in-orbit recycling centre or manufacturing centre. Now, again, this is all very high level and I would say probably quite futuristic, but the thing we need to get on with now is creating that international dialogue and cooperation. So like I said earlier, the UN would be a good mechanism for producing this framework for igniting a pathway towards technical and regulatory transformation. Like I said, they cannot dictate technical or regulatory transformation, but they can merely facilitate. So I just want to, I think I'm quite on time here actually, which I'm quite surprised about. So some final remarks. So firstly, space sustainability is a concept that we're hearing more and more in the media. We're hearing more and more in papers. There's more and more people interested in it, researching it, trying to create solutions. But it does have this limited and quite often misconstrued focus, and it's leading to ultimately leading to a paradoxical situation where the use of space itself to support sustainability is in itself actually becoming unsustainable. So what we've argued really here is that not enough currently is being done to tackle the problem, and that we really need a momentous paradigm shift in order to prevent negative trends from becoming the norm. And we've already kind of shown you in this presentation what some of those negative trends could look like. It's only then that we can actually see the benefit of space continue to be used and accessed by future generations. And I'm going to kind of leave in a quote here. So Dr. Guy Pignoli, who was an astronaut candidate for the French Space Agency, actually told me that we're likely to make the wrong decisions if we solely base our actions on cost and political agendas. The most important agenda is the survival of mankind. What most accords with this is what we should base our decisions on, and the political and financial agenda should be painted around this. It's time we stop seeing the environment as just our planet, but our whole solar system. If you've been interested in anything that I've talked about in this seminar, I notice it says look out for our upcoming journal article. It actually was just published on Sunday. So they've got a journal article called The Space Sustainability Paradox, which is in the Journal of Cleaner Production. Please go and have a read of that if you want to have any more information on anything that I've discussed today. And I'm not going to kind of have a discussion, but maybe just something to get you thinking about. You know, there has actually been recent calls to include an 18th SDG in the sustainable use of outer space. As we've shown through this kind of presentation, one of the main reasons for this is because space itself can be seen as a resource in itself. Of course, it's an infinite resource, but our orbits are not. And due to the limited availability of our orbital space near Earth, we're seeing orbital congestion, we're seeing space debris. So if we want to preserve that resource for future generations, it's been argued by a few that actually the current SDGs, so the Sustainable Development Goals, the targets and the indicators actually lack focus on this environmental impact, which actually renders them incomplete. But in reality, the idea has actually not gained any real traction in the multilateral community to date. So really what I would challenge you to think about is, you know, when we're seeing an increasing reliance on space to meet the SDGs, should we actually see space sustainability as a goal itself? You know, if not, you know, why do you agree with the international community? And if you do, you know, what should actually be included in the scope of that? So that concludes my talk for today. Thank you very much for listening, and I'd be happy to open the floor up to any questions.
Thank you very much, Andrew. That was very interesting. Of course, sustainability is important for us as human beings, but in particular also as space scientists, we depend on the space sector, so it better be sustainable. There are a bunch of questions coming in. The first question is from Patrick Essien, a space research scientist at the University of Cape Coast Atmospheric Research Laboratory. Yep. And the question is, space is open to every country and even private organization or industries for peaceful uses. Now, space is a destination also for tourists, and satellites are being launched into space day in and day out for different missions, though peacefully are not sure that in the future many debris will bring chaos, which will be more harmful to other spacecraft and even tourists. maybe I didn't read it grammatically entirely correct. But so I think the question is about these other uses of space, like tourism. They bring chaos and problems on top of the essential uses of space.
Oh, yeah, absolutely. So in the analysis we showed on the environmental impacts of space, we tried to capture a little bit of that. We actually expanded quite a lot on that in the other paper we did that was a follow-on to that. So that was called Environmental Sustainability of Future Proposed Space Missions. In that paper, we looked at impacts from proposed missions that include space solar power, space tourism, point-to-point travel, moon-Mars colonization, and of course that does present its own challenges. And that was really what we tried to capture there in that analysis, that actually when you scale up the industry, the impact becomes a lot more concerning. Now, you could argue that when we're talking about kind of moon Mars colonization, it could be a good or a bad thing, because if we did colonize the moon, perhaps we could create a manufacturing center on the moon which makes in-orbit recycling perhaps, I'm not going to say easy because nothing's easy in space, but perhaps more feasible than it currently is now. So yeah, I fully agree that it has its own challenges. I really don't want to think about the environmental impact that would be associated with point-to-point travel, which was something Elon Musk proposed at the IAC in Adelaide in 2017. So it brings about its own challenges, and that's why I would say now that it's so important that we get this right from the start, because we need to be more proactive with these kind of situations than reactive, which is traditionally what has happened in the space sector today.
Thank you, Andrew. I just discovered the button that I can allow participants to talk. So, Patrick,
Okay.
do you want to comment on that?
Yeah, hello.
Hello.
Can you hear me?
Yes, I can hear you.
Yeah, so I'm the Patrick guy who asked the first questions. I'm speaking from Ghana specifically. Yeah, so I wanted to know something about space, outer space colonization, because you know, when the United Nations Outer Space Affairs came out, or the couples came out with this space law, there were so many things that were not existing by then. Now, I think space science and technology is becoming advancing and then advancing. Don't you think that in the near future, outer space will be colonized? And this can bring, confusion between organizations or the nations that are embarking on this project?
Thanks, Patrick.
Yeah. So okay. So to answer that, yes, the way that it's going, if the plans that are ongoing are intended to be believed, then yes, I do believe Mars and the Moon could be colonized. In terms of answering your question, I generally try and stay out of astropolitics, but it does, you're correct in saying, bring a lot of logistical challenges. One of them is these kind of what I would call zoning. Okay, so of course, you know, the Moon Treaty says, for example, that you know the Moon's a common heritage of mankind. Nobody can lay claim to it. Blah blah blah. But if the US were to land in, say, the South Pole of the Moon, they could create almost like a zone on the Moon that, for example, the Russians or the Chinese then couldn't kind of go into, if you like. Now, what happens in the scenario that where the US lands in their zone, there's an abundance of water, for example, discovered there. It creates potentially conflict on another body. Logistically, it's also very difficult because you know, are humans actually even equipped to live on another celestial body? It's another kind of matter, and I'm, you know, again looking really far down the line, it almost sounds like science fiction. Throughout human history, we've also seen you know, what's the word I'm looking for? Colony civilizations eventually want independence. Again, what happens if the moon or Mars then become self-reliant and want independence from Earth? So there's a lot of if, buts, and ands, and The problem, like I think you very correctly identified, is that technology is vastly outpacing the speed in which legislation can keep up. And it's something that I believe needs a lot more legislation, but by the time we implement something, it will probably already be outdated. So how we manage that then becomes very important. And I would love to have an answer for you, but I don't know at this point what the answer or the solution would be.
Thank you, Andrew. I have a question of myself also. As a European space scientist, it's the European Space Agency, ESA, that is our, let's say, our point of contact. So how can we influence ESA to well, I should first say it's us space scientists who are lobbying ESA to have more and more launches and more instruments in space. So we have a responsibility there too, but what can we do in this context as individual space scientists to move towards a more sustainable use of space?
So for me, I suppose there's two different aspects to that. It's making sure that any additional spacecraft you have or are wanting to launch there are necessary to fulfill goals, adding data that will contribute to knowledge and not just being a duplicate of another spacecraft that's already still operational. So that's one part. But for me, the main part is I would suggest really looking at what the amazing work that the Clean Space team are doing at the European Space Agency. And they've been really pushing this kind of sustainability agenda for the past 15 years or so now. 14 years, I think, actually, but almost 15 years. And really, they look at kind of everything from in-orbit servicing to design for demise. And I think very importantly, if you're, and I'm more an environmental scientist, they also quantify the environmental footprint. So for me, the key thing is implementing eco-design into the design of any spacecraft that you're planning to launch. So design it in a way with the environmental footprint and the sustainability aspects in mind. And that way you can kind of create a baseline of this is what my spacecraft's environmental impact will look like. How can I actually reduce that even further? And you can do that in a way that actually, allows you to keep the technical specifications, so the mission requirements, the mission objectives, whilst actually actively contributing to reducing that environmental footprint. And of course, we've got a long way to go before we actually, achieve space sustainability. But actions like that are very noteworthy and a good starting point for reaching sustainability.
Thank you. I'm gonna allow Lucas Pogli to ask a question. Go ahead, Lucas.
Hello, can you hear me?
Yes, very well.
Yes.
So I would like to thank you, Andrew, for this very interesting talk. I apologize for some noise, but I am outside. So concerning your point below the discussion you just had, of course, space weather is not the world space activities, but for sure the existence of the sustainability working group is exactly to bring the voice of sustainability to some important tables. So E-SWAN can be for sure the body that can support sustainability of space for the space weather, but it can be for sure supporting all these issues you mentioned for what concerns the space weather part, of course. So just to remind you all that. And thanks again.
Okay, thanks, Luca. Andrew, I have one more question from Veronique Delouy. Practical questions. Are there tools in place that allow to assess all aspects of the life cycle, including what consequences if we do this or that for the end of life of a satellite?
Yes, there are. So there is two tools that I am aware of. There is the European Space Agency's Life Cycle Assessment Database. And there's also the database I developed at the University of Strathclyde called the Strathclyde Space Systems Database. And these are tools that can be used to quantify the life cycle impacts of a space mission, a launcher, whatever. So I'll maybe just explain what the differences are. So the European Space Agency's tool is based in SEMA Pro, which is quite inexpensive software, but they are trying to create a converter tool so it can transfer into another type of software called OpenLCA. It's a lot bigger than the SSSD. It's based mostly on primary data, and it's basically developed for let's say stakeholders in Europe to use to calculate the environmental footprint over the entire life cycle of that space mission. So everything from raw material extraction, design, production, use, launch, end of life, etc., etc. The SSSD does pretty much the same. It's a little smaller, it's based on a little bit more secondary information, but the key difference there is it also includes societal impacts and costing impacts, and it can also be integrated into the concurrent engineering process, so it can enable active eco-design. So life cycle assessment, eco-design are two different concepts. Life cycle assessment, basically you would come up with a design, then measure it. Eco-design would actively look to reduce that impact during the design process, which is what the SSSD is kind of designed, let's say, to do. And with the SSSD, we also offer it globally. Now, both tools require the user to have an EcoInvent license, okay, because they've both been built on top of a commercial database called EcoInvent. What is EcoInvent? Well, it essentially has loads of data sets that we would need, such as, like, what are the emissions from the electricity grid in Poland, for example. It's something that we've kind of built on top of. So if you're wanting access to these, you need to make a request. So one is to the for the ESA one, it's the Clean Space team in the European Space Agency. You'll need to demonstrate you have an EcoInvent license. For the SSSD, it would be to myself through my company called Metasat UK. Again, same idea. You'd need to prove you have a valid EcoInvent license before access can be granted. But these are tools that have been used by a lot of stakeholders across the world. So in the SSSD case, it's used in 3 continents by several different stakeholders. ESA have got even more stakeholders, but all from kind of Europe, let's say. And there's also been work, I would say, by Thibault Marie, who is now at the European Commission, but he formerly was at the University of Bordeaux, where he looked at the issue of space debris and how can you integrate that into life cycle assessment. In both of those tools, that impact assessment hasn't been integrated yet, but there is plans, at least from the SSSD side, to integrate that as well.
Thank you very much, Andrew. We're gonna close the webinar here. The recording will be made available in a week from now or so. Thank you very much for your time and for your inspiring talk.
Thank you very much.
Bye.